Good morning. Hi, everyone. Good morning from Singapore, and a good day to those who are not in the Singapore zone. Hi, my name is Kun Min. I'm the Deputy Director of Sustainability of Pan United. Pan United is an Asia-based technology company that focuses on catalyzing change in the concrete space. The title of my presentation today is The Urgent Need to Reduce Embodied Carbon. For the next 30 minutes, I will be sharing of how Pan United uses a circular economy model to reduce the embodied carbon in our concrete products. I will be touching also on the importance of embodied carbon in the built environment. And also, I will also be focusing on the latest technology that Pan United has used in the form of carbon capture utilization, or CCU in short, to further reduce the embodied carbon in our concrete products. Something about Pan United. Our mission is to sustain smart cities for tomorrow. Pan United vision is to be a technology company in the concrete and logistics space. Our sustainability vision is to be a global leader for environmental sustainability in the concrete industry. Our sustainability goals. In 2030, we will offer only low carbon concrete. And what do we mean by low carbon concrete? Essentially, the carbon footprint of our concrete will be a reduction of 50% against the 2005 levels. And in 2040, we will offer carbon neutral concrete products. And last but not least, we aspire to become a carbon neutral ready-mix concrete company. Let us take a look at our vertically integrated supply chain. Just give me a minute to bring up my pointer. All right. Okay, on the left, this is our cement terminal located in Jurong Port in Singapore. And that's where we import and redistribute our cement to our concrete batching plants located island-wide in Singapore. Next, our ground granulated blast furnace slag, or GGBFS in short, a type of green cement production plant that is located in Johor, Malaysia. Our aggregates quarry in Indonesia, Karimun, that we produce natural aggregates, both coarse and fines, to Singapore. And last but not least, our concrete business presence spread across 3 countries: in Singapore, in Vietnam, Ho Chi Minh City, and in Malaysia as well. Okay, our competitive edge focus on 2 very important areas, and it is process innovation and product innovation. In the process innovation, we continue to disrupt with digitalized system that incorporates artificial intelligence, mobility, cloud, and data. And under the product innovation, we will invest in research and development for our products development. And at the same time, we continue to strive and adopt new technologies to expand our product range and, of course, to reduce our embodied carbon. Delivering close to 40% of Singapore's concrete demands means moving a lot of materials around, and that is a major logistic undertaking. The nerve center of the entire operation is our command center that operates round the clock to ensure concrete delivered on time. It runs on a fully digital platform for logistic and supply chain management that we have developed in-house, which we call AIR, or AIR in short. AIR simply stands for Artificial Intelligence for Ready-Mix Concrete. In Pan United, we use this AIR digital platform to reduce costs, optimize our supply chain, replenish raw materials, manage customer concrete orders. AIR also helps Pan United to optimize our truck fleets, deploy mixer trucks to the next available concrete plants, facilitating quality control checks and electronic billing. Our AIR Digital is made available for all companies, regional and global, where it can be plugged into existing operations and applied to every stage of a user company. Next, I shall touch a bit on our product innovation. Till date, we have developed over 300 specialized concrete solutions, and this is done through our research and development team of material scientists and engineers. And we often do this by collaborating with customers, our institutions, as well as consultants. And we continue to bring in new technologies and to develop our new products. And here is a snapshot of some of our low embodied carbon concrete products that we have supplied commercially, from aviation to healthcare, marine and ports to underground, as well as from aesthetic to residential, commercial, industrial, and last but not least, in the transport infrastructure. And let me briefly share about our low carbon concrete products, which we call CTB, or cement treated base, or Pan-use CTB, that is used in the aviation sector, and that is a new base materials under the asphalt layers. With this new CTB, is able to cushion the aircraft landing and able to distribute the heavy aircraft landing loading more evenly throughout the pavement structures. And by doing so, is able to prolong the lifespan of the runway, and at the same time meeting the very strict requirement of the FAA standards. And here is an infographic of our low carbon footprint concrete products that we have supplied commercially. Okay, exactly what are we so passionate about reducing embodied carbon? As you can see, in this Architecture 2030 report, predicts that the global building stock is expected to double by 2060. And basically, when we are talking about embodied carbon, there is no time to waste, and we must really act now. So exactly what is embodied carbon? I'm sure many of us are very familiar with the operational carbon, as you can see over here. And basically, these are the carbon emission associated with building energy consumption. And we have seen numerous developers sharing their achievement in reducing the operational carbon and reducing costs of their buildings. But what we are trying to emphasize is the counterpart of operational carbon, which is the embodied carbon. And truly, this is often neglected, in the space of carbon. Not only we should only be looking and focusing on reducing operational carbon, but we should also aim to tackle the reduction of embodied carbon, which is again very critical. And this embodied carbon basically are carbon emission associated with the manufacturing, transportation of construction materials, such as your glass, your steel, and of course, not forgetting concrete. And these embodied carbon emissions are locked in as soon as the building is completed, because at the early stage, during the design stage, if the consultants or the building owners did not specify the use of low embodied carbon of construction materials, these emissions, or rather when these buildings are being built with conventional normal materials, the embodied carbon will be locked in and it will not be changed during the lifespan of the buildings. And a closer look at a report that suggests, without targeted actions, the embodied carbon emission could surpass the operating emission of the buildings within the next decades. As you can see here, it will be a whopping 57% against the operational carbon 43%. And again, I must emphasize that the operational carbon of a building during the lifespan, it can be affected, it can be reduced. However, for embodied carbon, once the choice of materials are being decided and being built, there's nothing we can do to reduce the carbon footprint. And true enough, with this report, it shows that the urgency that we need to start to look at how can we reduce the embodied carbon footprint. This is a circular model that Penn United has adopted to reduce the embodied carbon footprint of our concrete products. From the start, from the input materials, so typically for concrete production, we use a binder, or we call it ordinary Portland cement, that acts as a binder in concrete. And we have the filler, which we known as coarse and fine aggregates, together with water and concrete admixtures to produce the ready-mix concrete used for construction. For Penn United, when we are looking through this list of materials that goes into concrete, we start to examine and ask ourselves which type of materials contribute to the largest proportion of carbon emission or carbon footprint of our concrete. And in this case, cement is the largest emitter or contributor of carbon emission in our concrete products. And we start to look at how can we actually reduce the use of this cement, or how can we actually replace it with a lower carbon footprint materials, which in this case will be a ground granulated blast furnace slag type of green cement that typically has less than 10% of carbon footprint of that of ordinary Portland cement. And next, through sustainable technologies, right, we are able to further reduce our embodied carbon footprint, which in this case, I'll be sharing on the CCU technology in my next few slides. And at the factory or the gate, right, we are able, to design and produce low carbon footprint products that encompass of low carbon cement, green cement, as well as using recycled materials to replace the natural aggregates. And this, when we send our concrete, right, to our customers at site, typically the carbon emission, right, from the input, which is the cradle, to the customer site, the embodied carbon emission from A1 to A3 typically has more than 98% of contribution. And that leaves the 2% during the delivery. However, for Penn United, even at 2% contribution from the delivery from our concrete batching plants to the site, we also uses technology. And just as I have mentioned a bit on our Air Digital platform, through truck optimization, we are able to reduce the diesel, and hence we are able to lower our carbon emission during the delivery stage. And also at our customer end, they are also receiving paperless DO and contactless e-billing, that further reduces the need of paper as well. And next, I shall touch on the technology that I have shared earlier, and which is the CCU technology. CCU typically stands for carbon capture and utilization. And the CCU technology that we adopt to reduce our embodied carbon is applicable for all concrete applications. It basically mineralizes carbon dioxide, and sequestration is able to occur. And more than that, this technology is able to use with other types of recycled materials, such as the GGBFS, green cement, or the recycled concrete aggregates in our concrete. And the emerging importance of CCU technology is the latest growing trend that we observe for the past 2 to 3 years. I think in the space of carbon capture is quite mature in that sense. But however, the challenge remains on how to use this CO2 in concrete products or even in other types of products. And from an independent report, it does suggest that the potential of using CO2 in concrete stands at the highest potential. And let me introduce you to our partner, Carbon Cure. CarbonCure is a Canadian clean tech company, and till date, their technology is being installed and used in 500 concrete batching plants globally, and over 15 million cubic of CO2 mineralized concrete is supplied globally. And in Singapore, Pan United, we are the first to use this CCU technology, and till date, we have more than 10 concrete batching plants equipped with this technology. We have also started using this technology in Malaysia not too long ago. And at the end of this year, we'll be having another unit installed in our Ho Chi Minh, Vietnam plant as well. So here's a snapshot of the chemical equation, that goes through when CO2 is being injected during the concrete production. This looping video shows that the CO2 is being injected during the concrete production in our central mixer. And through this reaction, a nano-sized calcium carbonate is being formed, and it actually creates thousands of seeding sites for hydration. So what you see here basically is a photo taken off from a scanning electron microscope at 30 seconds after CO2 is being injected. So over here, what you see here, the sugar cube-like structure, is actually the formation of the nano calcium carbonate. And with these 1,000 nano sites being formed, it actually improves and increases the compressive strength of concrete. And this gives, and Pan United see this as an excellent opportunity, to reduce the embodied carbon of our concrete products by reducing cement, and yet at the same time achieving the same concrete strength. In my next few slides, it will be a bit on technical, but I feel that it's important, to showcase and to highlight the technical acceptance and the capabilities of the CCU technology. Okay, over here on this left-hand side, under normal concrete, you can see this gray color. These are the cement particle. And during the initial precipitation, right, when water is being added, red color is representing the hydration products are being formed around the cement particles. And this continues to grow after 14 days. As you can see, more hydration products that is being formed around the cement particles. And typically, these hydration products are the ones that give strength to the concrete. Now, let's take a look at the CO2 mineralized concrete. So apart from the cement particles in the concrete, right, the yellow dots, those are the nano calcium carbonate seedings that is being formed around the cement particles. And during the initial precipitation hydration phase, you can see that the hydration products that is in red not only forms on the cement particles, but is being also formed around the seeding sites. And after 14 days, you can see more hydration products are being formed around the cement particles as well as the nano calcium carbonate seeding sites as compared to those of the normal concrete. And because of this reaction, it actually gives rise to three very important benefits. First one, it actually helps to accelerate the hydration. It gives a more uniform and homogeneous hydration in the concrete mixture. And last but not least, it actually reduces the porosity, as what you can see over here at my cursor. Look at the pores for the normal concrete and also the pores that's being reduced for the CO2 mineralized concrete. Okay, so for the next few slides, we will be comparing the normal concrete against CO2 mineralized concrete. But bear in mind that this CO2 mineralized concrete, there's a 5% of a cement reduction of the original mix design for the normal concrete. So very quickly, when you look at the compressive strength for your grade 20, 40, as well as 60, the strength exhibited by the CO2 mineralized concrete, okay, are quite comparable to those of the normal concrete, even with a 5% cement reduction. And for the concrete durability, which is of a major tension for most developer and also for consultants, right, is the concrete durability results that I'm going to show. So again, for the gray color, that is the normal concrete. The orange one is the CO2 mineralized concrete with 5% cement reduction. You can see the rate of accelerated carbonation. The resistance to carbonation is actually enhanced, slight enhancement. So with the lower number means that the more resistance to carbonation is being shown from grade 20 to grade 60. So by comparing both normal concrete and CO2 concrete, the CO2 mineralized concrete has a slight enhancement in terms of carbon resistance. And at the same time, for the chloride migration coefficient, it also shows the resistance to chloride penetration for CO2 mineralized concrete. It thus has a better performance in this area. And even so, for the half cell potential test, right, that you've seen here, okay, both normal concrete and CO2 mineralized concrete lies in the range of the low probability of a corrosion. And these are the few tests of the concrete durability, that shows equal, if not better performance in terms of durability, as well as for strength between normal concrete and CO2 concrete. And together with the fresh concrete properties, the CO2 injection has neutral impact on these various fresh concrete properties that you see here. The global endorsement for CO2 mineralized concrete, right, on the international front is being accepted and approved under the Canadian Standards Association, German Institute, the DIN EN 206-1, and of course, together with the ASTM C494 specific Type S admixture. And on the government support, the Chicago and Hawaii Department of Transportation have legislated the use of CO2 in concrete for all their public projects. In fact, for the New York Low Embodied Carbon Concrete Leadership Act, have also encouraged the use of CO2 in concrete. And the latest, the city of Langford, Canada, have also specified the use of CO2 in concrete. And on the home front in Singapore, the Building and Construction Authority of Singapore has also included the use of CO2 mineralization technologies in the latest Green Mark 2021 that was launched last year, November. And we have also garnered strong support from Singapore Green Building Council that has created a new product category called carbon capture utilization, that recognize and acknowledge, the sustainability efforts in producing this type of low embodied carbon concrete through CCU technology. And last but not least, the concrete performance has also been validated, by in Nanyang Technology University by two professors, Prof. Tan and Prof. Yang. And the next 1 to 2 slides, basically here are some of the users of the CO2 mineralized concrete, and some projects, some users are in the pipeline of using this CO2 mineralized concrete in Singapore. In the likes of JTC, JTC is the first regulator of Singapore that uses this CO2 mineralized concrete. JTC stands for Jurong Town Corporation, is the largest landlord of industrial building in Singapore. And together with the consultants and builders that you've seen over here as well. And just now I talked about JTC, I'd like to share with you some of the use case for JTC project. So I mentioned that JTC, is the first regulator to use this CO2 mineralized concrete in their project in this infrastructure at Lorong Halus, right? And after successfully using this, the next project, Semicon Space, they have in fact specified the use of CO2, 100% use of CO2 mineralized concrete in their Semicon Space project. And not only that, they have also specified the use of green cement at 30% replacement of ordinary Portland cement in their project. And quickly, I shall go through the CO2 savings, what they have achieved should they didn't use the CO2 mineralized concrete and the GGBFS. So for the Lorong Halus project, total volume supply 5,000, and the CO2 reduction is 83,000 kilograms of CO2 in total. And for the semicon space, till date, as this is an ongoing project, till date 8,000 meter cube was supplied, and 931,000 of kilogram of CO2 has been reduced at this moment. So what we can see here, through the use of replacement of natural aggregates with recycled aggregates and recycled materials, together with CCU, we are able to reduce the carbon footprint from as high as 420 to 150. And that is more than 60% of reduction of all the 270 kilogram of CO2 per meter cube being reduced. And what we really want to envision in Singapore, and that is, if the use of low carbon concrete at 270 kg of meter cube, 270 kg CO2 per meter cube of concrete, right, we are able to reduce close to 3.13 million tons. And this 11.6 million cubic is the Singapore concrete production last year. So the effect is quite significant, and that 3.13 million, we are talking about close to 6% of Singapore emission. And I'm coming to the end of my presentation, and what we really want to encourage and to really emphasize, in order to reduce embodied carbon, we need, all stakeholders to take actions, and everybody has to play a part, right from the government, what we, as a very good example set by Chicago or even in New York, we can actually consider, setting a legislation in place to use CO2 and to reduce the embodied carbon in our concrete products or even in construction materials. Or at the same time, we are able to probably consider financial incentive, right, for users, to start to embark on using these low embodied carbon materials. And for the developers, to really just to build net zero embodied carbon projects, and to really emphasize the necessity, to use, and in this case, if you recall in my earlier slide, Capital Land is also one of the developers, that we have worked with, and they have really pushed the boundary of reducing the embodied carbon in their projects. And they are the first to use the CO2 mineralized concrete in their superstructure in their latest project, and have also specified the 100% the use of it in their projects. And consultants as well, being the QP of the projects, is also important, for you all to really prioritize and to educate the clients to specify the use of carbon materials, and to even optimize the structure design and continue to seek innovative solutions, and not only to place the emphasis on reducing operational carbon, but at the same time, take a look, at the embodied carbon in your construction materials, in your glass, in your steel, or even in your concrete, because these are very critical, and consultants have a very large part to play as well. And last but not least, for the materials manufacturers, for us, like Penn United, we are continuing our journey to reduce our embodied carbon, through digitalization, through product and process innovation. And we are also, on the journey to really, how can we actually certify this carbon emission in our concrete products, so as to give the project owner and the consultants a very clear guideline on the carbon that is going into their projects. I'd like to end off with this quote, from a very famous writer, Helen Keller. Alone we can do so little, but together we can do so much. So in this journey of decarbonizing the built environment, especially in the embodied carbon, I think the built environment sectors, we need to collaborate and we need to come together so that we can really effect the change to a wider aspect. And with this, I thank you for the time. This is my contact number with my email address. We are happy, to take any questions. Please feel free to reach out to us, and we can, in fact, share more in details of our sustainability journey and efforts. Okay, with this, I thank you for your time.